Hey guys, I'm back here, DIY DB, Do It Yourself by Dan B. And today, pag-uusapan natin how to make an automatic do-it-yourself garden watering system. This is a simple solution yet effective on way to automate your watering of your plants. And why would you do that? First, sometimes for some reason, you tend to forget to water your plants, and when the plants doesn't get enough water, the pressure inside the stems and the leaves drops and they wilt. And the other most likely reason is that, say, the whole family is going out for vacation and you'll be away for like several days or maybe a week or so. So here you'll start to worry on who should take care of your plants, basically watering them. So with this simple DIY solution, which is also cost effective, with just less than $4, you should be able to make this do-it-yourself automatic garden watering system. So if you guys are ready, let's get it on. Alright guys, first let's talk about the parts or components required for this project. But as I always say, there are several ways on how you can accomplish this DIY component-wise. But our DIY today is quite simple, that you only need the following components. So let's start with the first one. Here is the sensor or the probe. And this is nothing but a two-leg probe sensor which is used to check the humidity or the moisture of the soil. So this guy is to be inserted in a pot where you have your plants, and that will take the reading of the humidity of the soil. Okay, so what happens is that the value that's being taken by this probe is then compared to the constant value that you are about to set on this second component known as the sensor module. So this sensor module right here is actually a microcontroller by itself, and that's the reason you don't need Arduino for this project. And this microcontroller, as you can see here, it has a potentiometer right there, which is something that you can configure to set the parameters. So whatever values being read from this probe is then being compared to the one that you set here as a constant value. And the idea behind this one is that, if the sensor, if the sensor detected by the probe, has a low humidity, which means that the soil is dry, which has a low humidity value than the constant value here, then that would then trigger from this microcontroller to send a signal to another component, which is our relay. So this is our third component, the relay. So whenever there's a low moisture generated based on the values compared between the probe and this microcontroller will send a signal to our relay, which is then activates the pump, which is nothing but these two wire here, our port component, which is connected right here, and then it gets energized, and once the pump get energized through the plastic tubing that is connected to the pump right here, the fluid or the water will get displaced, and this will come out right here to the other end of the tubing, which is obviously connected to the pot or the plants that you want to water. So it looks very simple. As a matter of fact, the principle behind this is very simple. And the last component that we have here is, of course, our jumper cable or our wire. So if you don't have a jumper cable, you can use your ordinary wire. Speaker wire will do. I'd like to use jumper cable because if you look closely here in some of our components, they have this pin right here, and if you have a jumper cable, you can just insert it right then and it should connect the wire in place. So much easier to use a jumper cable. So yeah, so there you have it. As far as the parts, and if you guys are worrying about where to get these parts, don't worry about that, because I'll be listing all these components right down in the description and where to get it as well. And like I've said earlier, all these parts to be able to do this DIY will definitely cost you less than $4. So this is again a do-it-yourself automatic garden watering system. Hey guys, so let's start with our wiring here. As you can see, I made a simple diagram on how we were going to interconnect everything. So you guys can just follow this, and you can just fix your connection, and that's it. But for me to be able to do this, I will start with a breadboard. Okay, so breadboard is a way of kind of like a flexible way of testing your circuit before you fix them into like a fixed connection. So I'm gonna make use of a breadboard here, and we're gonna do exactly what we have here in our diagram. Okay, so as you can see in the diagram, we have our sensor probe. Okay, so right here, so I'll start by connecting two cables or two connections right here down to the sensor module. Okay, so I got two here. Okay, I'm gonna stick this on right here in one of the connection. Okay, and the other one, the blue one, should go to the other terminal as well. Okay, so we got the module now. So we get this two line right here. Like as you can see here, these are the two that we have connected. So the other end of the module should go to our sensor module right here. So in this case, this is our sensor module. Okay, so we get the two connections right here, and then all we need to do is just connect the cable down to the two terminals right on this side as well. Okay. All right. So there you have it, guys. We actually made this connection from the probe right down to the input of our sensor module. Now what we need to do is work on these remaining connections or remaining terminals that we have here. Okay, so let's start. The first one that you see here is BCC, which is actually a 5 volts. Because this sensor module is driven by 3.5 to 5 volts. Okay, so what I'm gonna do now is I'm gonna connect another cable right here. Okay, on the BCC. So BCC is the one here down below. So I'm gonna connect here. Okay, so this is a 5 volts. Okay, so here I will just stick it on here on the breadboard right here, and I'll explain later on how are we going to provide the 5 volts. Okay, so I'll stick it on here on the red rail, as you can see on the breadboard. Okay, now we have another one here on the middle. Okay, it says ground, G and D. Okay, so so what I'll do is I'm gonna get another jumper wire, connect it here to the ground. Okay, and then the other end should go to the blue rail right here, which will serve as our ground. Okay, so we get here our positive 5 volts, and then the ground right there on the blue rail. Okay, if you want to make it more precise, you could probably do some color coding with your jumper cable or jumper wires as well, but unfortunately I have limited jumper cable, so I'll just do this connection on the fly. And then right here, coming back to our diagram, the third, I'm not sure if you could see it, it's a bit skewed, but the third pin right here is DO, or digital output. Okay, so I'm gonna connect again. I'm gonna connect here. Okay, on the third pin. Okay, I'm gonna connect the other cable right here. Okay, and then it says here that this digital output should go as an input of our relay. Okay, so here I'm gonna get our relay right here. Okay, and that should be the input of our relay right here. Okay, if you look here in our relay, the first pin on top is input. Okay, let me just refocus this. Give me a second right here. I'm trying to refocus my camera so you guys can see the label on my relay. I'm having a hard time, but yeah, there you get it. On top is, you can see IN, that's input. So that will be the one that will send signal to our relay. Okay, also, so again, I'm gonna put a cable right here. Okay, I'm gonna put a cable right here going back to the sensor module. This is DO. Okay, that will be the output. Okay, and that output should go as an input to our relay. Okay, so this is a relay, on top is the input. Okay, so there you have it. Okay, now we're done with our sensor module, because the last one here is analog output, we don't need to use analog output. We're just concerned on the digital output. Okay, so this is kind of like activate the switch high and low. Okay, if this is closed, then it would energize the switch. If this is high, then it sends a signal to activate the relay. Okay, now so let's move on and work here on our relay. Okay, if you look here on the relay over here in the diagram, you can see in the middle it's also ground. Okay, that's why we have a black line here then pertaining to the ground line or the ground connection. So similarly, the sensor module has a ground where they are connected and going to a ground line. Okay, so for me to be able to do that, I'm gonna connect another cable right here. Okay, on the relay on the middle pin, which is the ground. Okay, connect it, and then coming back up here again, remember I told you earlier the blue line or the blue rail is actually our ground, so I'll just stick it on here on the blue, align with the other connection. So whatever you see here on the blue line, if you're not familiar with a breadboard, if you try to energize this and connect this, all this line right here are connected. The line that you see here vertically, they are connected as well. So that's how breadboard is flexible in terms of testing your circuit. Alright, so the other one here is actually our ground. Okay, coming back to our relay, so I'm gonna stick on the ground connection. Oh, sorry, the positive or the 5 volts, because this relay is also driven by 5 volts, and then the other end should go right here on the 5 volts. Okay, so I think we're pretty much it. Alright guys, so as you can see here, we are down to we're done with our sensor module. They are now connected accordingly. Okay, similarly our relay is also connected right here on this side. Now we are down to this side here where we need to connect our connection. So we have to connect our pump now. Okay, so if this is our pump, and I put some cable right here just to kind of like connect it to the breadboard, as you can see here. So this is the positive, or the positive line. So if you look here on our connection, the positive should go to the COM of the relay. Okay, so this is our relay right here. I'll just gonna unscrew this connection right here. Okay, and then I'm just gonna connect the positive. Okay, so please bear with me here. This is something that I've been doing on the fly, and I really wanted to see how it works as well. So now I'm just trying to tighten the screw with my positive connection of the pump connected to the COM of our relay. Okay, so now we're down to that. Okay, it's now connected. Now if you go back to the relay, there's another one here, the NC connection, which is also should have a connection all the way coming from our positive 5 volts. So I'm gonna grab another wire here, and I have a red cable here that I can use to kind of like depict it to be the positive line here. Oh, sorry, this one is different out, so I might need to get another wire. Please bear with me here. Alright guys, so I got this wire right here, which will serve as the COM connection or the NC connection right here. So I'm gonna connect it again here on our relay. Okay. Okay, so now the wire here is connected, so the other end should go to the positive line or the 5 volt power supply. So again, this is the red rail right here, so I'm just gonna stick this on to the red rail. Okay, so that's it. I think we're good. our pump is now connected. So what I need to do is just connect this plastic tubing here right on the pump. Okay. Okay. I think we're ready. Okay. The only thing we need to do at this point is to be able to provide a power supply. All right. So for that, guys, Alright, for the power supply, I made a customized USB cable right here where I just need to plug this onto a power bank, and the output of this cable is actually a two pin connection, a positive, the red, and the ground or the negative, which is this black. So I'll just need to stick this on, okay? So I'm gonna stick this positive right here, okay, on this red rail, and then the negative or the ground on the blue rail. Okay, so that's it. Hey guys, we're back here to do the actual demonstration. So as you can see here, we're already had our connection established here to our breadboard, and what we need to do now is to plug these 5 volts and plug it to our power bank right here to be able to provide the 5 volts right here on this rail. Now you might probably ask, why 5 volts? Because well, to begin with, if you look on the data sheet, if you look on the description here for the sensor module, this module here is driven by a 3.5 to 5 volts. And similarly, this particular relay here, if I'm not sure if you can see it, but it is written at the back, that is a 5 volt. It needs 5 volt power supply to be able to energize the relay. And same thing for our pump. This is a pump that is operating within 3 to 6 volts, so 5 volts should be good enough. So now that we have our connection, the next thing we want to do is to be able to plug in our supply, which will feed power to our breadboard rail right here, 5 volts, and the ground or the negative. So I'm gonna connect this right here now. So as you can see, you can the moment I connect it, you can hear that the pump is working. That's the sound coming from the pump. And there's the LED right on here, which means that our relay is activated and the pump is running. So what I gonna do now is, you see the sensor here. This one, it determines the behavior of the pump, right? So if it gets a lot of humidity, meaning the area where this is deep on has enough water, then this should turn off the relay and then turn off the our pump. So let's see here. I'm gonna dip this one in this. I'm gonna dip this down here in this water. As you can see, the moment I put it in here, the pump stops, and then the LED or the relay deactivates as well. So that's what we would like to see here. So now I'm just gonna put this right here on the actual plants. As you can see now, as I stick it here on the plant soil is still not it's still dry. Okay, now what I'll do next is I'm gonna submerge the pump into water, and with the plastic tubing, the other end of the plastic tubing attached here on the plants here, as you can see. All right, I'll put it here on. Now I'm gonna dip down here the pump, and now the water starts moving. See, the water, as I move it here down, the water immediately displaces from the pump, from this container through the pump, and all the way right here to the plants. Now the pump stops because the water is already now wet, or the humidity now is high. So as simple as that. So every now and then there will be a value. See, there will be a value. So if I take this out, if I take this sensor out, put it in the air, you'll see that the pump will start running again. See, then I put it back right there and it stops. So that is something that will happen every now and then. This sensor will keep sending a value to our sensor, and there will be a check every now and then. And the moment that the soil is dried up, then the pump will start displacing water to our plants, and that would create our do-it-yourself automatic garden watering system. In less than $4 you should be able to do this. So now that we're done with this, the next thing we want to do is to assemble them all together, because we know that our circuit works. Assemble them all together using our diagram, and then you might want to put it in an enclosure. Make sure that our electrical components are protected, especially this sensor right here. Okay, this sensor, has an electrical connection, so you might want to put some electrical tape around it, or maybe put in some enclosure to make sure that they are protected once you deploy them outside. So yeah, so that's about it. So if you like this video, please don't forget to subscribe, and of course click on the like button. And if you have questions, just connect down on the comment section, and I'll be glad to answer whatever questions you might have. So till then, this is DIY saying keep on charging and take care, stay safe.